Welcome to our channel Kavita Ashok Educational and Motivational channel. Today we are going to discuss permutations combinations part 6. Up to part 5 you want to see, just subscribe our channel and go through it. Now we will discuss 2 marks questions. If NP4 is equal to 1680, find N, and if 12P R is equal to 1320, then find R. So these two are very important for 2 marks question. How can we solve? Now we will discuss. Right. What is given here? NP4 value is given 1680. Right. NP4 in the sense we already know starts with the N. 4 in the sense we have to write 4 adjacent terms. 1, N minus 1, N minus 2, N minus 3. Once look at here, 1, 2, 3, 4. This is equal to 1680. Now we have to write 1680, the product of 4 terms, 4 adjacent terms, consecutive terms, right? We will write like this, 1680. So 0 is 0. So first 1680 is 0. I am starting with 8. 8 2 ja, 8 1 ja, this is 0. Now 7 3 ja, now 6 5 ja. We want 4 consecutive terms. Yes. Now we will write this as 8 into 7 into 6 into 5. 4 consecutive terms. So finally this is what? NP4. And we can write this is 8, 1, 2, 3, 4 terms. 8P4. So finally what is the value of N? N is equal to 8. Like this we can calculate. Now second one. 12PR is equal to 1320. Already first term is declared. So that's why 1320 we are dividing with 12. 12 1 ja 12, 12 1 ja 12, 0, 11 1 ja 0, 0. So 12PR is equal to 12, 11, 10, 12P3. Then R value will be 3. Like this we can calculate N value as well as R value. We will discuss on 4 marks question. Right. 56PR plus 6 is to 54PR plus 3 is equal to 30,800 is to 1. So how can we write this one? 56PR plus 6 by 54PR plus 3 equal to 30,800 by 1. First take the cross multiplication. Now 56 PR plus 6 into 1 is equal to 30,800 into 54 PR plus 3. Right. According to the formula of NPR, how can you write NPR? NPR is equal to N factorial by N minus R factorial. So that's why we will write this as 56 factorial by 56 minus R plus 6 factorial. This is equal to 30,800 into 54 factorial by 54 minus R plus 3 factorial. Now 56 factorial can be written as 56 into 55 into 54 factorial. And this one 56 minus 6 is 50. 50 minus R factorial. This is equal to 30,800 into 54 factorial by, and this is 54 minus 3, 51. 51 minus R factorial. Now 54 factorial get cancelled. Next 11 5 ja, 11 2 ja 22, 11 8 ja 2000. Next 5 1 ja, 5 5 ja 25, 5 6 ja 560, 56 1 ja 56 10 ja. So finally what we can get here? Nothing is there here now. 1 by 50 minus R factorial is equal to, here we can get how much? 10, just 10. 10 by, now this is 1 by 50 minus R factorial, that is equal to 10 by 51 minus R. This one get cancelled. So cross multiplication. 50. Now 51 minus R is equal to 10. Just take this 10 to the left part. 51 minus 10, then R value will be 41. Now we are going to discuss one important problem and one important concept. So many problems depends on this problem. If we understand this problem clearly, we will solve the remaining problems very easily. Okay, so this is also important for 2 marks question. Look at now. In how many ways 9 mathematics papers can be arranged so that the best and the worst may come together and may not come together? Right, listen carefully. Right, how many papers are there? Total 9 mathematics papers are there. Just take M1, M2, M3, so on, M9. 9 mathematics papers are there. They are going to conduct this exam. Total 9 papers are there here. In these 9 papers, they want to give 2 papers. How many ways, how they want to give? May come together. What they come together? The best and the worst may come together. Right. In these 9 papers, one best paper and one worst paper is there, according to them. Okay. Now, these 2 papers come together. This is our condition. So, whenever come together is there, okay, those 2 papers consider as one unit. Look at here now. The best paper and the worst paper. Consider these 2 papers as one unit. Okay. Plus remaining how many papers are there? Out of 9, 2 papers are there. Yeah. Remaining 7 papers are there. So when the papers will become a unit, each paper is also act as one unit only. So here 7 papers also will become a unit. So total how many papers? 7 plus 1, 8. 8 units. Is it clear now? Whenever one we consider as a unit, then remaining each paper act as one unit. So that's why 7 plus 1, total 8 units. Okay, right. If no condition is there, 8 papers can be arranged in, we already know 8 papers can be arranged in 8p 8 ways. That is nothing but 8 factorial ways. Okay, but what he says here, best and the worst come together in the sense here, may best after worst or worst after best. Maybe BW or WB. So we can arrange these 2 again in 2 factorial ways. These 2 papers, best afterwards worst, worst afterwards best. So that's why 2 factorial. According to the fundamental principle, the total arrangements are 8 factorial into 2 factorial. So there is no need to calculate. Just keep like this, we can get the marks. Once again, whenever come together is there, consider those 2 papers as one unit. When we consider this as unit, remaining papers also will become units. So total 7 plus 1, total 8 units. 8 units can be arranged in 8 factorial ways. Now in these 2 papers, best and the worst, 2 papers are there. Again we can arrange in 2 factorial ways. So total by fundamental principle, the first work can be performed in m ways, the second work can be performed in n ways, 2 works simultaneously can be performed in m into n ways. So 8 factorial into 2 factorial ways. Now go for the second. What he says here, may not come together, but the best and the worst may not come together. So here the condition is for best paper and the worst paper, not for the remaining. So whatever it may be the condition, just remove that, leave that conditional papers, best and the worst paper, just leave that papers. Remaining how many papers are there? 7 papers. So 7 papers, 1, 2, 3, 4, 5, 6, 7. These 7 papers we can arrange in 7 factorial ways. Is it clear? Now the best and the worst may not come together. That means for them 1, 2, 3, 4, 5, 6, 7, 8 choices are there. If we put these best and the worst paper in these places, then automatically it satisfies the condition. 8 choices are there, 2 papers are there. We can arrange these best and the worst papers in 8p2 ways. Is it clear now? Again, whenever condition is there, leave that conditional papers. First arrange the remaining papers. 7 papers are there, we arrange it in 7 factorial ways. After that, how many places are there to put those papers? 8 places are there. Only 2 papers are there. How can we put? 8p2 ways. So again by fundamental principle the answer will be 7 factorial into 8p2. So like this we can arrange. This is very important problem. So by using this concept we will solve the next 4 marks question. Now we will discuss one more 4 marks question. So many times they give this question in the annual exam. Okay. By using the previous question concept we will solve these problems. Right. What he says here, find the number of ways of arranging 6 boys and 6 girls in a row. So first we will discuss that. Right. N is equal to, how many boys? 6 boys are there and 6 girls are there. Total N is equal to 10. 10 students. N is equal to 10 students. Now, if no condition is there, 6 plus 6, 12. 12 members are there. There is no condition is there, we can arrange these 12 persons in 12 factorial ways. So, number of arrangements is equal to, so 1, 2, 3, so on up to 12 places are there, sir? 12 elements. We can arrange them into 12 factorial ways. This is the answer for the first question. Right. What he says here, in these 12 factorial arrangements, the first condition is what? All the girls are together. I told you, whenever together is there, we can consider all girls as one unit. How many girls are there now here? 6 girls. First consider 6 girls as one unit. Plus, remaining how many persons are there? 6 boys are there. So whenever we consider this as unit and each boy act as one unit. So total 6 plus 1, 7 units. Now 7 units can be arranged in 7 factorial ways. 7 units can be arranged in 7 factorial ways. Now in these 6 girls, 6 different girls are there. They may interchange. So 6 girls, automatically 6 places are there for them. They may interchange in 6 factorial ways. By fundamental principle, the number of arrangements will be 7 factorial into 6 factorial. Is it clear? The same manner in the second question, what he says here, no 2 girls are together. No 2 girls in the sense here, any 2 girls are sit together. So the condition is for girls. First leave that girls. How many boys are there? 6 boys. Arrange those boys. 1, 2, 3, 4, 5, 6. These are the places for boys. 6 boys can be arranged in 6 factorial ways. Now for the girls, how many places are there? 1, 2, 3, 4, 5, 6, 7 places are there. But how many girls are there? Only 6 girls. So we can arrange the girls in these 7 places in 7p6 ways. First arrange the boys, later arrange the girls. Is it clear now, sir? So after arrangement of 7 places are there. In those 7 places, we keep 6 girls in 7p6. We already know empty places are dominated in the sense we can take it as n. If girls are dominated in the sense we can take girls as a n. Here empty places are dominated. So that's why n is equal to 7. 7p6. Again by fundamental principle, 6 factorial into 7p6. Like this we can arrange. Now, right. Now what is the third condition? Boys and girls come alternately. Right. Boys and girls come alternately. Whenever come alternately is there, first arrange the seats. How many members are there? 12 members are there. First arrange 12 seats for them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. First arrange the seats. Now arrange here in these 12 places 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. In this 6 even places are there and 6 odd places are there. Okay. First arrange boys in 6 even places. Boy, boy, How many boys are there? 6 boys. How many even places are there? 6. How many ways we can arrange? 6 factorial ways. Now for the girls, what are the remaining places? Odd places. 1, 3, 5, 7, 9 and 11. How many girls are there? 6 girls. So in the 6 places, we can arrange 6 girls in 6 factorial ways again. So we can arrange 6 factorial into 6 factorial ways. Is it clear? Now we have the doubt. Here, in this arrangement, the starting place is girl. Why don't we start with boy? Yes, your thinking is correct. We may start with boy also. Means again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If we start with a boy, 1, 3, 5, 7, 9 and the 11th place will be occupied by boys. 6 odd places are there. We can arrange these boys in 6 factorial ways. Again, even places will be filled by the girls. 6 girls are there, 6 places we can arrange in 6 factorial. So, there are 2 choices. Either the row starts with a girl or the row starts with a boy. So, that's why we can get 6 factorial plus 6 factorial plus 6 factorial and 6 factorial. So 2 times of 6 factorial into 6 factorial. Like this we can arrange alternately. Once again recall that. Come together in the sense, consider that as a one unit. Remaining also becomes the unit and we can arrange. Alternately, do not come together in the sense, no 2 girls come together in the sense here. First leave the girls, arrange the boys, in the remaining places arrange the girls. That is the condition. Alternately in the sense, first arrange the total number, the total seats. Either it starts with a boy or it starts with a girl. Like that we can arrange, then we can get the answer. This is so many times asked in the annual exams. So repeatedly listen the video. If you have any doubt, just post a comment. I will explain once again.